Do you ever feel confused when you hear the word model in tech? These are the things that are behind the movies that you watch on Netflix, the reels that you see on Instagram, and probably even the reason you picked this video out of all the other ones that you saw on YouTube. Today I'm going to turn that confusing buzzword into something that actually makes sense. That way, next time it's brought up with friends, family, or at work, you're actually going to know what's going on. At the end of the day, a model is just a simplified view of reality. And when it comes to a machine learning model, well, that's just a trained predictive brain. Let's dive right in. The problem is that humans are too slow. And the solution is to use a model because it's an automated decision maker that gives the computer the ability to make predictions at an unimaginable scale and speed. Let's take the house market for example. Let's say you wanted to price a house. It's pretty easy. Maybe you can look around at similar houses in the neighborhood and figure out what you think this value of this home should be. But when it comes to millions of houses, that becomes a much more difficult problem. This is where you need an automated, scalable system. YouTube is also a great example of this. YouTube can't hire a bunch of different humans to figure out what type of video should we show to every single type of user out there. That's way too tedious, it would never be scalable. But this can be handled by a sophisticated recommendation system, which is built from many different machine learning models. For example, one model could predict the likelihood that you're going to click on a video, which is called a classification problem, while another could be predicting the likelihood that you're actually going to enjoy the video, which is called a regression problem. Now that we understand why machine learning models are useful, let's look into what types of machine learning models exist. There are generally three different types. There are supervised learning, unsupervised learning, and reinforcement learning. Let's bring us back to when we were in school. Supervised learning is like learning with a teacher. You give the model labeled examples, this is a cat, this is a dog, or this house was worth $1 million, this one's worth 600,000. It then learns the relationship between the inputs, so the pictures of the animals, or the city, square footage, neighborhood, or value of other similar homes, and the desired output. Is it a cat, or what is the house value? Within supervised learning, there's two different types. There's classification, which is a discrete output, so either a cat or a dog. And then there's regression, which is a continuous output. And there could be infinite possible answers like the value of a house. Unsupervised learning is like learning without a teacher. You just give the model the data, and it will find the hidden patterns and groupings all by itself. This can be like giving it the data of a bunch of different people that watch YouTube, and it will find patterns in the users. Maybe it finds some users are interested in sports, others into makeup, and this is super useful because it will help them decide what kind of videos to recommend to those users. And the third is reinforcement learning. This is the one that's kind of similar to trial and error. Let's imagine we want a model to figure out how to get out of a maze. The model will learn more and more every single time because it takes an attempt, and if it was a bad attempt, it will get penalized. And if it was good, then it gets rewarded. And the model wants to minimize the amount of penalties and maximize the amount of rewards. So this could be like training a model to figure out its way from the beginning to the end of a maze by retraining itself multiple times until it figures out when to turn left, when to turn right, when to go straight, until it gets to the end. Okay, now how do you actually create a model? Coming back to that student example, the process of creating a machine learning model is called training, and we can think of it as a student that's trying to learn how to solve a problem. For supervised learning, it happens in 4 essential steps. Step 1, gathering the data. The data is the raw information the model learns from. It's the collection of real-world examples, like all the houses sold in your city over the last 10 years, along with their features, the size, age, number of bedrooms. Coming back to the analogy, the data is the textbook, full of solved problems and example. A good model needs a lot of high-quality examples to learn from. Step 2 is to choose the actual algorithm. The algorithm is the mathematical recipe the model uses to find patterns in the data. It dictates how the computer will connect inputs to the outputs. Common recipes include linear regression for simple predictions or neural networks for complex image or language tasks. Step 3 is training the actual model. The algorithm starts with random internal numbers called parameters or weights. Think of these as a set of knobs and levers inside the model that determines how much importance is placed on each input. For example, how much does square footage matter versus the number of bedrooms? And in the end, the model is considered trained when all those internal knobs or parameters are tuned to a good enough setting that minimizes the overall error and allows the model to make the most accurate predictions possible. The last step is to test all of this on your actual data. To make sure that the model is actually a good predictor, we need to give it some sort of a final exam. At the beginning, we split our data into two parts. The training set, which is what we did all of the steps above with. And then there's this little extra set called the testing set, which is what we use at the end to test and see if the model is actually good at what it's trying to do. So the goal here is to test the model on data that it has never seen. And if it does well, then we can confirm it has truly learned the pattern and didn't just memorize the answers from the training set, kind of like a student. Now for the scary part, which is actually really not that scary, I want to show you how you can actually create your own model using Python in less than a minute. And for those that are not at all savvy with Python or coding, still stick around. It's very interesting to see how easy it is to do. It literally looks like English. We can do this in literally 6 lines. And we're going to run a very simple linear regression model, which is basically just a line through our data. So to do that, we're going to import the linear regression package from sklearn. Then we're going to provide the data, and in this case, it's a super simple example where we have 3 different rows of data. We can see the square footage and the price of 3 different homes. So we can see one home has 1,000 square foot and it's worth 200,000. Another is 1,500 square foot, 300,000, and so on. And the goal here is we want to be able to predict the price given the square footage. So here we can actually create the model by writing this. Then we can train the model on the data. And then finally, we can predict the price of a home that has 1,750 square feet. As you can see, a model is just a trained mathematical simplification of reality, meant to make our lives a bit easier. And so next time someone's talking about a model, you'll know it's not some piece of magic, it's just some fancy mathematical equation. If you like this video, make sure to watch one of these 2 videos because they were specifically chosen for you by a machine learning model. So that's gotta mean something. Thanks for watching.